about, and then I will be discussing about the what are the material can be used for the matrix material and can be used for the reinforcement material. As we know that in any composite material there will be two main constituent. One will be the matrix material who will hold the reinforcement material or who will act as the binding materials. So similarly for the reinforcement material who will strengthen the whatever the mechanical properties or material properties after manufacturing will come, so those will be given by the reinforcement material. So those I will be discussing. After that I will be discussing what are the different techniques which is available nowadays in the market for the manufacturing of the polymer reinforced composite material through additive manufacturing technique. There are many different techniques, but our concentration is there using additive manufacturing process, how to manufacture polymer reinforced composite material. Yes, similarly what are the material consideration will be there. As we know that in all material which is available in our environment, that can't be printable. So coming to the polymer material also, all polymer material can't be printable. So because of those reasons, so selected material till now only they are manufacturable using the additive manufacturing process. That's why I will be discussing about those material which can be printable using additive manufacturing techniques. And then I will be also discussing about the what are the process parameters and how to optimize those process parameters for the manufacturing of the polymer reinforced composite material for the having better mechanical properties, better microstructure, better bonding strength between the reinforcement and then matrix material. So those I will be discussing about. Similarly, I will be discussing about what are the applications of that particular additive manufactured polymer reinforced composite material. So, and then I will be discussing about what are the testing and characterization method is required for whatever the material is produced using additive manufacturing process. So those testing and characterization I will be discussing in detail, so that one should know about the complete understanding about their mechanical properties and then microstructure properties. Then what are the challenges and then limitation of the additive manufactured composite material will be there. So those challenges and particularly polymer reinforced composite material I will be focusing on. And then I will be also discussing about the what are the future trend and the research direction for the polymer reinforced composite materials. So now I will be discussing about what are the current manufacturing trends for 3D printing polymer composite material. So those things I will be discussing about. So in that mostly I will be discussing about what are the technologies are available for the composite material. So first is that fused reposition modeling. So it is one of the widely used. So I will be discussing in detail one by one about these techniques. So in detail in coming slides. So next is the selective laser sintering process. So SLS in short we are calling. So similarly the SLA and digital light processing will be there. Stereolithography and digital light processing techniques which can be also used for the making of the polymer reinforced composite material through additive manufacturing processes. Similarly I will also discussing about the multi-materials, functionally graded printing materials. So here also functionally graded material, composite material can be also fabricated using this technology is multi-material technology. Similarly the continuous fiber reinforced 3D printing technology, or in short we are calling the CFRP 3DP processes. So those all also I will be discussing about. And then I will be discussing about the ultrasonic and microwave assisted 3D printing technologies which is available for the manufacturing of the polymer reinforced composite material. So and after that, in the last, I will be discussing about the additive manufacturing, like friction stir, deposition and the cold techniques for the making of the composite material. So in coming to this diagram, you can see that in this diagram there are different 3D printing techniques are presented here. So material extrusion, vat polymerization, material jetting process, and the powder bed system. And then here in the, it may be filament can be used, ink can be used. It means these are the material. Similarly for photosensitive resins and powder bed system. And then similarly some of the material which can be. Now coming to the manufacturing of the polymer reinforced 3D printing materials, composite materials. For that, one of the widely used techniques are fused deposition modeling. So in this fused deposition modeling techniques, the extrusion based techniques are there that can be used for fabrication of the object or any composite, any materials layer by layer, melting and depositing thermoplastic filament through heated nozzle. So in this, whatever the filament are used, that will be coming from the spool, and those which is passing from the nozzle, heated nozzle, and after that it will be extruded from the this nozzle, and then it will be depositing on the whatever the shape and size of the final product that is desired. So that material will be coming out and it will be depositing on this surface, and then layer upon layer printing will be taking to the final like product layers. So in this way product will be manufactured. So this process involved heating the polymer materials above its glass transition temperature and extruding it in the controlled manner. So in the controlled manner only, how much quantity of the material, heated material is required to depose onto the surface, only those quantity of the material will be coming, and then it will be deposited on this surface. So it is one of the widely used techniques due to its low cost, design flexibility, and its compatibility to print functional polymer composite material. Similarly, the like carbon fiber, graphene, CNT, carbon nanotube, and ceramic filled polymers are used to enhance mechanical properties, thermal properties, and the electrical property of the composite material. So some of the commonly used materials are PLA material, polylactic acid material, ABS material, PEEK material, PE, KK material, and then TPU material, and some of the material which can be also filled with the nanofiller material to strengthen the whatever the mechanical properties and other properties, maybe electrical properties of the final product. So for that purpose, sometimes nano material can be also filled with, or maybe sometimes one can fill with maybe natural fiber reinforced composite material can be also possible using this techniques. So coming to these are the fused deposition modeling. From that we can manufacture 3D printing composite material also. So coming to the here our next process. So in that our focus will be there selective laser sintering for the fabrication of the polymer reinforced additive manufactured composite material. So in this you can see that this is the schematic diagram. So in this schematic diagram you can see that this is the laser. So here in this laser energy are used, so that's why it is mentioned. So one can use the electron beam energy also, one can use the plasma beam energy also, depends upon the what kind of the source of energy are used. Based on that it will be mentioned. Similarly, when the laser light is passing, so that laser light will scan the given certain area in which the part fabrication will be required layer upon layer. So laser will scan only those area, not the entire surface area, because on the whatever the powder is spread on that surface, only some area we require to manufactured, so that's why laser will scan those area only, so that energy will pass to the whatever the laser beam energy will be there, that laser beam energy will transmitted to the powder, and then powder will be getting heated, and then finally it will be partially melted. So in this SLS process, partial melting of the polymer powder material will be taking place, and then once partial melting will be taking place, and then fusion of the molten material between the adjacent powder liquid material will be there. From that fusion will be taking place, and then after solidification they will make the one layer of the printed material. So in this way phenomena will be taking place. So now coming to there are two chambers used. One is the like a powder delivery system, and another is used the piston fabrication piston. So in the powder delivery system, this system are used to store the powder material, so that whatever the required amount of the material will be required for the one layer powder. So this from this chamber only this required amount of the one layer powder will be sprayed on the fabrication piston, and then laser will be scan the required area as per the design model, and then fabrication will be taking place. So once this one layer printing taking place, so what will happen, this fabrication piston will come down by one layer thickness only, so that only next layer will be that much thickness material will be sprayed again on the fabrication piston, and then printing will be taking place. So this way this selective laser sintering process will be working out. So commonly so in this as sometimes we have to perform the preheating of the powder material, and it's sintering in the defined pattern. So sometimes preheating is also important factor, because sometimes you have to uniformly heat the material. So other technique of 3D printing technology for the making of the polymer reinforced composite material include the stereolithography, or simply we are calling it SLA, and the digital light processing techniques. So in this digital light processing technique and the SLA process, so what is happening there, so this light will be scanning the whatever the liquid material are used in this liquid material, so that the liquid will be converted into the solid material. So here the phenomena like photopolymerization phenomena will be taking place. So here what happened, whatever the liquid material or resin material are used, that has to be photosensitive material, so that whenever it will be initially this liquid material will be in the liquid stage, that time it will be in monomer phase. So when the light processing or passing will be taking place, so interlinking of the monomer will be taking place, so that monomer will become the polymer. So here layer upon layer also building taking place, and then here the whatever the layer will be there or liquid will be there, so those layer will be scanned by light energy system. So in the light energy system you can know that here the only certain area, only a very small area it will scan or fall on the liquid surface. So a small area only it can cure it, or it can solidify it one time scanning. So it will take more time for the printing or scanning in the entire area, and then solidification will be taking place. While in this configuration the projector light are used, so those projector light will cover the wide area of the material in which the liquid printing will be taking place, or maybe curing will be taking place. So in one go it can scan the entire area, and the solidification will be taking place the given area itself. So it is the faster process than the this SLA process. But in both the process the same photopolymerization phenomena will be taking place. So So that's why here I have mentioned here the photopolymerization based additive manufacturing techniques that are used to induce the polymerization to the cured liquid resin to layer by layer techniques. So it will employ, or it may use the ultraviolet light or UV laser light for the selective curing of the process or material, while DLP using the digital projector for the faster printing process. Both the process, it will involve the cross linking of the material, or reaction will be taking place that we are calling the polymerization process. So similarly, it maybe sometimes we have seen that we are making the composite material. So in that composite material, one material will act as the binder, another material will act as the reinforcement. So binder material will be here in this process will be used as the resin material. In that resin material, some of the powder particle like ceramic, it can be ceramic, or it may be carbon, it can be graphite, or nanotube will be there, or maybe some other naturally available powder form material will be there. So those can be also used like basalt fiber, or it may be carbon fiber, glass fiber, maybe like banana fiber, jute powder. So these are the some of the material can be also used for the reinforcement purpose. So depends upon the what kind of the application that printed part can be used for that purpose. The one can use the what kind of the strength and other properties will be required as per the requirement. Only one can use the powder material. So suppose sometimes we require high powder high strength material, composite material. So in that case one can go for the higher strength reinforcement material, so that it will increase the more mechanical properties or strength of the properties. Some of the material just I have discussed about it can be ceramic material, it can be graphene, it can be CNT, to increase the mechanical properties, thermal properties, and then electrical properties. So commonly epoxy include epoxy material, or resin material includes the epoxy resin, similarly acrylic and the polyurethane resin material. So other technique that what are the used in nowadays is multi-material and the functionally graded printing process. So in multi-material and functionally graded printing techniques, more than two materials they are using, and then layer upon layer printing will be taking place in all additive manufacturing techniques. So what will happen, certain layers they will print with the certain functionally graded material, so they will behave differently compared to some other layers. So in each certain layers will be having the higher mechanical properties, lower mechanical properties, or maybe some smart properties will come. So expansion, compaction, so some other feature can be also achieved. So in that way one can go for the whatever the mechanical properties will be there. So as per the mechanical properties the functionally graded material can be generated. So some of the techniques, commonly used techniques, include the FDM method. So in that FDM method one can use the multiple nozzle. So from one nozzle one material will come, and from other nozzle another material will come. So in that way we can make the composite material, and that too also having the functionally graded properties. So each layer will be behave differently in a different scenario when the application will be used. That cases. Similarly, it can be used using the powder bed system process. In that case, DMLS technique or SLS process can be also used here. So in that case, one can use the a certain layer of the powder having the some properties. Similarly, certain layer of the powder will some other properties. So or some other powder can be used, or that powder can behave after solidification differently than the other layers. So in this way one can make the functionally graded composite material. So similarly one can use the wet polymerization phenomena also, like a DLP process, SLA process, for the making of the composite material that I was discussing about the last slide also. So other printable material include the thermoplastic and thermosetting material, like PLA material, ABS material, PEEK material, PEK material. Similarly, epoxy resin material with the powder, any ceramic powder reinforced, or maybe some other banana fiber, basalt fiber, or maybe other naturally available powder material reinforced. So from that, similarly, the one can use the conductive and the smart material for the making of the CNT, graphene, piezoelectric materials. So for the sensing and the energy harvesting process. Similarly, it can be used like biopolymer based material like sits on similarly collision and then hydroxy apatite material for the biomedical implant making. So coming to the continuous carbon fiber reinforce the 3D printing process. So in this process, what will happen? This is also one kind of the FDM machine itself, FDM printing machine itself. In that, in place of the chopped fiber or in place of the particle reinforced, one can use the continuous fiber, the carbon fiber, and that can be reinforced in the whatever the binding material will be there. On those binding material, it can be supplied. So continuous fiber, it can be like carbon fiber, glass fiber, Kevlar fiber, and into the polymer materials during the printing process. So it will increase the whatever the strength of the polymer material will be there. So those strength will be increased compared to without reinforcing the material. So similarly, this 3D process can be also used for the making of the powder material reinforced with the liquid material, so that one can act as the for the better superior mechanical loading condition. So some of the printable material include the PLA material, ABS material, nylon, PEK material, similarly carbon fiber, glass fiber, salt fiber will act as the reinforcement material, while these are the PLA, ABS, nylon and the PEK material will act as the binding material, or you can say that matrix material. Some of the challenges of this process include anisotropic material. Like in anisotropic material, the mechanical properties will be different in different direction, but in the case of the isotropic material, different direction or in all direction, whatever the mechanical properties will be there or material properties will be there, those material properties will be the same in all direction. So one has to be know about, suppose you are moving in the certain XYZ direction or any other inclined direction, so those direction mechanical properties will be same or material properties will be same. But in the case of the composite material, here layer upon layer printing will be taking place, so in certain direction mechanical properties will be different. Similarly, certain direction tensile strength will be more, certain direction compressive strength or compressive force will be different, compression strength will be different. So this is the directional properties materials which is achieved after the additive manufacturing process. So other techniques involve ultrasonic microwave assisted 3D printing techniques. In that techniques, what is the happening there? So this ultrasonic transducer will be there. So those ultrasonic transducer will make the vibration to the heated nozzle, and then because of the heated nozzle, whatever the polymer material are passed, those will be heated properly and it will be uniformly mixed. Whatever any foreign material are mixed, so it will increase the bonding strength between the different layers. So similarly, the uniform distribution of the any foreign particle are used for the making of the composite material. So uniform distribution of the here you can see that without making the reinforcement ultrasonic vibration, and with the ultrasonic vibration you can see that uniform mixing of the all material will be taking in the binding material or matrix material and the reinforcement material, so that uniform. So this will increase the interlayer bonding strength, so this will lead to the higher mechanical properties or material properties after manufacturing process. So in this process one can use the FDM process, one can use the DLP technique, similarly one can use the other technique also. So here whatever the technology which is used for the nozzle based, so that can be used FDM process we can use. easily. So some of the like commonly used material will be there, ABS material, PLA material, PEEK material as compared to similar. So only difference will be there here, additional ultrasonic vibration will be given to the nozzle, that will lead to the better mechanical properties, strength properties while making the materials. But in the case of the additive manufacturing friction stirred welding process and the cold spray techniques, so in this process what will happen here, the we are using the which is the tool, that tool will be rotated with the very high rotational speed, and it will be in contact with the substrate material, and it will move in the direction. So in this way itself, in the tool itself, feed stock will be supplied. So this feed stock will be also rotating, and then with the rotation it will, because of the friction, the material will be melted, and then it will be deposited on the where the path will be there, on those path, and layer upon layer building will be taking place. So sometimes we can change the materials layer upon layer also. So one layer, one feed stock will be supplied, another layer, another feed stock material will be supplied. So in this way the printing of the material will be taking place, and then binding will be phenomena will be taking place. So here now we will discuss about the key process parameter of the additive manufacturing polymer composite material. So some of the key process parameter is almost the same for all additive manufacturing process. So that includes the layer thickness. So if you increase the layer thickness, in that case the amount of the energy which is supplied for the printing also may be required higher. If the higher layer thickness will be there, so it will decrease the resolution of the print quality, or you can say that print maybe sometimes print quality will be not good. Similarly, sometimes the bonding strength will be also not proper because of the higher layer height. So one has to optimize the what is layer height, optimal layer height will be required for the particular product. So based on that only one can recommend, and then one can use that certain layer height. Similarly, printing speed also. Printing speed is also one of the important factor. So it is nothing but the how your layer will be scanned. So there itself the printing will be taking place. So scanning speed, so at what rate your nozzle is moving. Suppose if it is related to FDM process, so in that how your nozzle is moving. Similarly, if it is the powder bed system, in that powder bed system, how your energy beam is supplied, or how your energy beam is scanning the area where the powder is already spread. So that will decide the printing speed here. So this will influence the build time and the printing quality. So if your scanning speed is faster, in that case what will happen? Sometimes the energy which is required for transmitting from the laser energy to the material which to be printed, that is not transferred properly. So uniform melting, partial melting of the material will be not even taking place. So that may lead to the some other defects. So in that way it will decrease the print quality and the strength of the material. So similarly, some of the other parameter, that will be the nozzle temperature. So nozzle temperature is also important factor. Why? Because in the nozzle temperature, suppose you are not achieving the higher temperature, whatever the temperature of the material is required. Sometimes we require a higher melting temperature material. So in that case, if your nozzle is not able to achieve those temperature, then how melting will be taking place of the whatever supplied or stock material is there. So melting will be not taking place. So in that case, you have to ensure that whatever the maximum temperature or the nozzle is achieving, those materials should be also having the similar kind of the melting temperature. Then only proper melting will be taking place and the deposition will be taking place. So similarly, in coming to the other parameter, that include the bed temperature. So sometimes if the proper bed temperature is not given, in that case what happen, when whatever the material is falling or coming out from the nozzle, those will be deposited on the build platform. So build platform temperature is not uniform, so what will happen, there will be chances of the warping phenomena or maybe some adhesion related issue will come. So that's why one has to ensure that whatever the optimal temperature is required for the print bed, so that temperature has to be supplied before starting the printing. Then uniform adhesion and then warping issue will be resolved. So similarly, raster angle and the print pattern will be there. So raster angle, it will also decide about the orientation of the extruded path. Similarly, it will affect the mechanical properties of the anisotropic properties of the materials. So this also it is very, very important parameters. So similarly, infill density and infill pattern. So in case of the infill pattern and infill density, first one should understand about what is the meaning of the infill density. Infill density is nothing but the how much inside filled about those material when it is printed. So suppose you are taking the 100% infill density, so what will happen, total complete printing of the inside taking place, so it will be complete solid material. But sometimes we do not require those inside material, so in that case one can go for the decreasing the infill density, like 80%, 70%, 60%, 50%, even one can go for a 20-30% also, no issue. In that case you are going to save the material if that much strength and other properties is not required in that case. So similarly, coming to the infill pattern can be of any profile, whatever the profile inside the printing process. It can be like a triangular, it can be like cubical, or it can be like a hexagon, pentagonal shape, or it can be honeycomb structure. So those way the printing pattern will come. So one has to know about the what is the printing pattern is there. So if you are choosing one pattern, so one pattern to another pattern, the mechanical property will be changed because their inside infilling will be different. So similarly, they are coming to the extrusion rate and the flow rate. Extrusion rate is nothing but the amount of the material which is extruded or coming out from the nozzle. So if the amount of the extrusion is more, so more quantity of the material will be coming and it will be deposited. So it may lead to the too high or too low, can cause the gap and overfill or less fill the material. So it may be, so that's why one has to avoid certain kind of the parameter selection. So similarly, build orientation as I was discussing earlier also. Suppose if you are making the one bottle, so that bottle can be printed like in vertical way, or it can be printed in the horizontal way. So if you are printing your part in the vertical way, so what will happen in that case, your compressive strength of the part will be higher compared to when you are printing the same object in this orientation, horizontal orientation. So in that case, tensile strength of this built part will be higher. So in this way, one can have the higher mechanical properties.